Okay. A review of the coordinate plane that we did last week, middle of last week, we will be combining the concepts from the coordinate plane into the functions and their rule. I'll just give it to me. I'll just correct them. Just give me your paper now and I'll correct you. It's always a problem. With the x-axis being here, the y-axis being here. Okay? We had what was called an ordered pair. What was the order of that ordered pair? Which came first, x or y? Casimir. Yes, x came first, followed by y. So that when we would get an ordered pair, 2, 3, for example, I would go first of all to 2 on my x-axis. Then from there, I would go to 3 on my y-axis, and it would put me there. Okay? We did that whole two-sided worksheet, 60-plus problems, or about 60 problems on the coordinate plane. Most of you did very well with that. Are there any questions in review? What happens when we had an ordered pair like 4, 0? I would go to 4 on my x-axis, and then from where would I go on my y-axis from there? Nowhere, so it would stay right on the x-axis. Okay. Now today, what we'll be doing is taking a look at functions, and we'll be taking a look at a function table and then graphing. Okay. So let's take a look at an example here, like y is equal to x plus 3. Here's the rule. I'll fill out the table. And what they want us to use, they'll give you values for x. So they're going to go -2, -1, 0, 1, and 2. So in your notes, make sure you get this down. Okay. Make sure you get that down in your notes. You'll understand it much better if you participate, actively participate, not just watching me. It's always easy when you watch me do it. You'll need to be able to do it on your own, too. So let's fill in accordingly. Fill in my values for y once I know x. So a -2 for x plus 3. Where does that put me for my value of y? If I'm at -2 and I add 3, here's the number line right here. -2 add 3. 1, 2, 3. Where is that? Here's -2. 1, 2, 3 puts me at 1. Number, or the next one, a -1 plus a 3. So 1, 2, 3 puts me at +2. 0 plus 3, 1 plus 3, 2 plus 3. Now, we already talked about ordered pairs, x, comma, y. Here, we have a bunch of ordered pairs that were solutions to my rule. So we're going to graph the first one, -2, 1. Graph the next one, -1, 2. 0, 3, 1, 4, and 2, 5. Pardon me? Well, for this one, we're moving up. You're not going to move up for everyone. You might move down. You might move up. It doesn't... What matters is what, Casimir? The ordered pair. What you get for your solutions when you plug it into the equation. This particular one, yeah, we're going up. Does that mean we go up every single time? No, not necessarily. But what you're going to find out is I've got these dots, these points on the coordinate plane. The next step is to, not the straightest line in the world, draw a line through it, and then we're going to label that line as y is equal to x plus 3. Okay? If I'm not able to draw a straight line through the points I put on my coordinate plane, what does that tell you? What does that tell you? If, let's say, I had a point that was like over here somewhere. What do you know about this point over here? Casimir? You probably didn't do it right. Because if you graph these functions correctly, these are linear equations. And what do you see in the word linear? Line. If done correctly, when you connect all the points together, you should get a straight line. What else does this tell you? What do the arrows at either end of this line mean? What do the arrows on either end of that line mean? Say. Huh? Right. What do they mean? Yeah. What about these arrows? Is this line done right here? Right here, is it done? Zakaya. Keeps going up this way, keeps going down this way. The arrows mean I don't have to draw it to the ceiling. I don't have to get on a chair and draw it to the ceiling and get a ladder and draw it all the way up to the roof. Or start crawling down the stairs and start drawing that line further down, all the way down through, Mrs. Barant's room downstairs. I just put these arrows on. What does the line tell you? Any point that falls along this line, their coordinates, their ordered pair, would also be a solution to that equation. That's why I label it with that equation, with that rule. Any point that falls along there, okay? Where's this point here? Did I even have this one on there? No, my points were in red. 4, 1, 2, 3, 4, 5, 6. It's like at 4, 7. See that? 4, 7. Is 4, 7 a solution to my rule? If I put in 4 for x, do I get 7 for y? Yeah, I do. So anything that falls along your straight line would also be a solution to your rule, to your equation. That's why you draw the line. Okay? Any questions there? You try one. Y is equal to x minus 2 is your rule. And let's say, pretty consistent, -2, -1, 0, 1, and 2. And then I'm going to want you to kind of make your own little grid here. When I give you your worksheets, you'll have your own kind of grid to use. But -1 minus 2 puts us where? Who's got it? Negative what? 3, 0 minus 2, 1 minus 2, 2 minus 2. There we go. So we got these ordered pairs. Negative 2, negative 4 is going to be there. Okay? Negative 1, negative 3 is going to be there. 0, negative 2, there. 1, negative 1, there. And 2, 0 is going to be here. Okay? So from there, we're going to draw a straight line through our points. And this isn't very straight, but I'm doing it freehand. Do what? Label it as x minus 2. Okay? Put the arrows on each end, and we're good. Maybe you had it work out. How many of you had it didn't have it work out because you didn't have these right? It's okay if you didn't. That's why we do them in class, to work through it. Okay? Other than that, it's just the order of pair stuff. I'm going to give you a sheet. We're going to try a couple of these together. Take one and pass it down. Take one, 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 pass it down. Let's take a look at worksheet 13-4, first of all, not 13-5, 13-4. Number 1 says, for each function, make a table of values, then graph the function. So number 1 gives us y is equal to x plus 5. They make the table like this. It doesn't really matter. I prefer to have it written vertically, but, you know, horizontally is fine as well. Negative 2, negative 1, 0, 1, and 2. So let's plug in the values and find out what our coordinates are going to be. So if x is negative 2, negative 2 plus 5 is what? 3. Very good, Eli. If x is negative 1, and I plug in negative 1 for x, add 5, 4. 0, 1, 2. So these are all my coordinates. Now, right next, or right underneath it, they give you a mini grid. So you're going to use that grid right now and graph these points. Do that right now. Did you write that on your line? Your straight line. There's a train going through. Okay, so if we're negative 3, there's a train going through about this way here. Somewhere on your graph, it should be about there. But the name of that train has to be labeled, okay? So we know what train is passing through. So the arrows are good, Larissa. Absolutely, we need the arrows. But we also need to make sure we label it. Casimir. Do you remember the ordered pair? Remember that this is your x-axis and this is your y. Remembered all that? So all I'm doing is saying, okay, negative 2, 3 is my first point. So I'm going to put my point there. Did you put all your points down? But you didn't what? Oh, well, do you understand it, though? Or you still need more work with the line? Well, we're going to go through some more. We'll get it worked out. Number two is a little bit different. It looks like this. Y is equal to negative 5. What's different about this equation? Doesn't tell us what is? It just tells us that y is equal to negative 5. So when I see y, what am I going to put there? Negative 5. I see another space for y. What am I going to put there? How about here? I mean, that's what it says. Y is equal to negative 5. So they could care less what x is right now. I can make up whatever I want for x. If I wanted, I could add a 3 for x. What would y be? Okay. So on my graph, let's see how that looks. Yeah. So my first point, negative 2, negative 5. My next one, negative 1, negative 5, 0, negative 5, 1, 2, 3. I should have a bunch of straight lines right at the bottom, or dots going in a straight line. I need my arrows. I'm going to label this as y is equal to negative 5. Okay? Now, when you get to algebra, they'll be asking you certain things like, is this a function? Is it not a function? Once you graph it, there's something called the vertical line test. And if one of the graphs, one of my linear equations passes the vertical line test, then it's a function. And what that means is this. Could I draw a vertical line through any point of the line I just drew, and it would only cross that line one time? One time, one time, one time. Or you get into a problem where they're not functions, is when you get a line that graphs out like this. More of like a parabola. And then you'd say, oh, well, if I do the vertical line test on this, it would cross here and it would also cross there. That's not once, that's twice. It's not a function. Okay? Yes, there is a such thing as this. Absolutely. And we'll get to that later. But you got a couple of years to worry about that. Number 3. Number 3, the directions. Graph the function y is equal to negative 2x plus 3. Then tell whether or not each ordered pair lies on the line. So let's take a look at what we have. And I say, let's just use the same x values that we've been using. So we've been graphing for negative 2, negative 1, 0, 1, and 2. Okay, so you're going to work through this one with me. Make sure you got all this down. And even though they don't have this on your sheet, you're going to put it on your sheet. Right next to, you've got that open space next to 3 through 6 there. Go ahead and make yourself that little table there so we have that to reference right away. I'll wait for you. All right, so I'm going to take my values for x, I'm going to plug them in. So here, it's negative 2, my value for x is negative 2, plus 3. I multiply before I add. What's negative 2 times negative 2, Edsel? Can you please pay attention? What's negative 2 times negative 2? 4. 4 plus 3 gives us a y value of, now we'll do the same thing. Plug our negative 1, negative 2 times negative 1 is positive 2 plus 3. Plug in our 0. Negative 2 times 0 plus 3. What's negative 2 times 0? 0 plus 3. Plug in our 1. Negative 2 times a positive 1 is what? Negative 2 plus 3 is 1, positive 1. Negative times a positive is always a negative. Negative 2 plus 3 puts us at a positive 1. Negative 2, plug in our positive 2. Negative 2 times a positive 2 is a negative 4. 2 times 2 is 4. Negative 2 times positive 2 is a negative 4. Negative 4 plus 3, is that enough to get us back to 0? No, we fall 1 short. There it is. Those are our coordinates. So let's take a look at our graph and let's graph that line. Okay, so a negative 2, 7 puts us way up there. A negative 1, 5 puts us here. A 0, 3 puts us there. A 1, 1 is here. And a 2, negative 1 is there. So when you draw your line with your arrows on it, and we're going to label it y equals negative 2x plus 3. Okay, so you label that. Now we're going to be set to answer the questions. Give you a second to make sure you get that all labeled. Now, what do they want to know for numbers 3 through 6? Eli. They do, but specifically, what do they want to see? We had to find out this before we could answer 3 through 6. Read the directions. Liam. So let's look at the first one. It's 0, 4. 0, 1, 2, 3, 4 is right there. Is that red point on our green line? No. Look at it. We have a 0, 3. You can't have 0, 3 and 0, 4. So this red, although it's close, is not on the green line. Negative 3, 9. Well, negative 3, 9, we don't know for sure. So what can we do? Plug in the negative 3. Does it give us 9? What's negative 2 times negative 3? Positive 6, right? 2 times 3 is 6. Negative times negative is positive. Plus 3, is it 9? So yeah, we could say it would be on there, yes. Number 5, a 3, 5, or 3, negative 5. Plug it in. Negative 6 plus 3 is what? 3. Is that 3, negative 5? That's 3, negative 3. Does that work? No, it doesn't work. 3, -3 is going to be about there. Didn't fall on it. And then 2, -4. Did we use a 2? Did we use a 2 for x? Was it -4? No. So that doesn't work either. 2, -4 is down there. That doesn't fall in it either. Okay? So sometimes you make that line, and you can tell. So the only yes was number 4. Everything else were no answers. Flip it over. Graphing functions. I'm only going to assign to you numbers 1, 2, and 3 for tomorrow. Complete the function table. Here, let me show you something real quick so you don't get confused. For number 1, 2, and 3, they give you input x, and then they say output is 2x, okay? All of the values in that column are going to be your x. All the values in this one are going to be your y. So when they only give you 3 points, you're going to plug in here. Multiply this times what? 2. So -2 times 2 is? What? -2 times 2 is, right, is -4. 0 times 2. And 1 times 2. So these here are the coordinates that you're going to use on the chart that they give you. Okay? Plot them out, draw a line through them, make sure to put down, you can put down y equals 2x, same thing. Or you just put 2x, we can fix it tomorrow. Okay? So underneath there, they give you a little coordinate grid to use. Okay, so worksheet 13-5, numbers 1 through 3.